The magnetic levitation is one of the methods wherein a certain object, for example a steel ball, is being suspended into the air, having no other support than a magnetic field. This is used for it as a less contact, frictionless, and noiseless. This is considered to be a control system because it is unstable, an open loop, and non-linear. It has following applications. First is in military weapons engineering, such as the rocket and gun. For the environmental engineering, such as the small and huge wind turbines at home, offices, and industries. In transportation engineering, such as magnetically levitated trains, flying cars, or personal rapid transit. And in aerospace engineering, such as spacecraft and rocket. And for electrical engineering, such as magnets.
There are three basic elements under the controlling system: the plant, which is represented by a 0.5 inches steel ball diameter, and the sensor, which is represented by the photoresistor and the light-emitting diode, or the LED, and the controller. In this project, the student aims to float the steel ball through a magnetic field at its desired height. The two forces that are acting in the plant are the attractive force and the weight, which is equal to the mass times the gravity. There is an additional signal towards the controller through the received amount of light by the photoresistor, and the controller makes adjustments in terms of the strength produced by the present attractive forces from the electromagnet.
The mechanical equation is focused on the forces interacting towards the metal ball. It is given that the summation of all forces along the vertical line is equal to the mass multiplied by the acceleration. From the equation shown, the second term is linearized using Taylor series, where delta I is equal to 0 and delta Y is equal to 0. Solving for K. Recalling the equilibrium condition that I sub O, Y sub O, the speed of the ball is 0. The mechanical equation is, in deriving the electrical equation, it takes the summation of voltages around the loop with the electromagnet. The transfer function can be solved by using the state space equation using both equations 1 and 2. Substituting all values toward equation 3. Our transfer function would be
presentation of materials. In the fabrication process, the thickness of the plywood utilized is 3/4 inch with a dimension of 15 by 10.5 for its housing. The PVC pipe is 1/2 inch by 3 inch. A photoresistor that is used in the sensor LED with 100 ohms pull-down resistor.
In the fabrication and assembly of the magnetic levitation system, this requires various components, materials, and tools to enable to meet the desired goal. For the electromagnet, 6-inch long, 1/2 inch diameter bolt and nut, 1/2 inch diameter washer, 3 pieces, 400 grams of gauge 19 copper wire, mylar insulator 5 by 1.5 inches, and for the housing, 3/4 inch plywood 15 by 10.5 inches, stick well, PVC pipe 4 inch long and 1/2 inch diameter, power supply. For the controller, printed circuit board at least 7 by 9 cm, IN547 diode, OP amp LM741 2 pieces, and OP amp IC socket 2 pieces, 500 kilo ohm potentiometer 2 pieces, 33 kilo ohm resistor 1 watt, 10 kilo ohm resistor 1 watt 3 pieces, 500 picofarad mylar capacitor, 2N30558 transistor, heat sink, and for the sensor, connecting wires, light-dependent resistor, light-emitting diode, 0.5 inch diameter solid steel ball, and 220 kilo ohm resistor.
The first step for the fabrication process would be cutting off the plywood. Next is cutting off the PVC pipe. Next is soldering of the PCB board. In determining the desired height of the PVC pipe, it must be adjustable. The PVC pipe should be aligned with each other. Attaching transistors in the heatsink using screws. Connect the connecting wires towards the terminal. Winding of the electromagnet and the mylar insulator is coiled in the bolts and nut, making 1000 turns using copper wire. Arrangement of connecting wires in the terminal towards the PCB.
For the design and assembly of the control circuitry, we will start out as a schematic diagram shown in the figure. This circuitry will be soldered in a PCB and will be tested using a tester to ensure functionality. This part here is the controller composed of 2 OP amps, resistors, 2 potentiometer, and transistor connected towards the heatsink. Inside the case is an electromagnet which is perpendicular to the axis of both the PVC pipes, having the light emitting diode or LED and the light dependent resistor or the LDR.
For testing the magnetic levitator, so first, we need to plug in the 12 volts power supply before plugging the power supply. The 2 potentiometer must be turned on first to its least resistance value, adjusting potentiometer to vary the strength of the force. The position of the potentiometer must be connected in parallel to make the motion of the ball stable.